In this video, we'll be learning about the chain rule, which will allow us to differentiate composite functions. So to begin with, we're reminded of the formula at the top of this page, which states that if f of x equals to g of h of x, then its derivative, f dash of x, equals to h dash of x times g dash of h of x. Now, let's get started and see how we can use this formula to differentiate composite functions. Let's say we're given the following function. F of x equals to sine of x squared plus 1, and that we're asked to differentiate this function. Well, the first thing we notice when we look at this function is that it's a composite function. And indeed, we can see that there's an inner function here, which we'll call h of x. That's h of x equals to x squared plus 1. As well as an outer function here, which is sine. And we'll call this g. So that would be g of h of x. In other words, we're defining h of x, the function, as x squared plus 1, and g of x as sine of x. Now, we can now rewrite our function f of x as g of h of x. So that would be f of x equals to g of h of x. And so using the chain rule, we can now state that its derivative, f dash of x, must equal to h dash of x times g dash of h of x. And looking back at our functions h of x and g of x, we can easily differentiate these. Indeed, we can see that h dash of x equals to 2x, and g dash of x equals to cosine of x. So using these two results, we can now write the final answer, and that would be the derivative f dash of x equals to 2x times cosine of h of x, which was x squared plus 1. And there you go. We've just differentiated this composite function using the chain rule. Let's look at another example. Let's say we're given the following function. F of x equals to the exponential of cosine of x. That's e of cosine of x. Now looking at this, again we notice that this is a composite function. And once more we can see that we have an inner function, which here is h of x equals to cosine x, and an outer function, which is the exponential e. And so we can write g of h of x. So we've defined h of x as being equal to cosine of x, and g of x as e of x. Now that we've done this, we can rewrite our function f of x as f of x equals to g of h of x. And we can now state that this function's derivative must equal to f dash of x equals to h dash of x times g dash of h of x. And looking at our functions h of x and g of x, we can differentiate these. We know that h dash of x equals to negative sine of x, and g dash of x equals to e of x. And so replacing h dash of x and g dash inside our formula for the derivative, we find f dash of x equals to negative sine of x times exponential of h of x, and h of x was cosine x, so that's e of cosine of x. And there you go, we've just differentiated this function using the chain rule. And so that's how we use the chain rule to differentiate composite functions.